Okay, so I want to quickly go through this transportation LP problem, right? So we're picking the practice question we sent you. We ran through it. You've already been given the solution, but I'm just going to use this opportunity to explain how this was set up, right? So just quickly running through the question. It says Green Peppers needs to send their goods to its four customers. And then we have each customer is expecting an amount to be delivered to them, right? And as an operations manager, he or she needs to decide how much of each order to send to each customer from the two warehouses available, right? So this table is giving us some information, right? So let me quickly explain the information you're seeing here. So the information here is basically the cost is gonna how much is gonna cost to send the one item from warehouse one to customer one, and that's $1, right? If we come somewhere like here, this means how much is going to cost to send one item from warehouse to customer four, right? And so on and so forth. So you kind of get the picture of what the table is giving us. We also have some information down here, which is describing how much each customer has ordered. So customer one has ordered 35,000, customer two, 22,000, so on and so forth, right? So this and the table gives us enough information to solve the LP problem, right? So now that we've gotten a good sense of what the question is and understood the scenario, we then go to our setup. All right, so in the setup, whereas the objective is to minimize cost, we can see that from here, right? The operations manager wants to keep cost as low as possible. So in this case, we're trying to minimize the cost as much as we can, right? Considering all the constraints we have. What's our decision? We need to decide on how much stock from each warehouse to send to each customer. The information we have over here is the cost is sent from warehouse one to customer one, but we're not given how much is going to be sent from warehouse one to customer one, and that's what our decision variable is going to be. We need to decide on the amount that is going to go from each warehouse to each customer, right? It's very important to know that. That's the decision we need to make, right? Then we go into our decision variables. We have WOCO, WOCT just means warehouse one, customer one. I would have probably written it this way: W1 C1, W2 C2. But however I decide to do it, to make sure that you describe what that variable means, right? So now we've been able to get our decisions together with the decision variables. We need to come up with the objective function, right? Now to get the total cost of this entire operation, right, of this entire transportation operation, we need to figure out first the cost to send one item from each warehouse to each customer. I'm going to multiply that by the number of items that we plan on sending out, right? So we have the actual cost, which is our coefficient here, 1, times the amount that we're going to send from warehouse 1 to customer 1. And we do that for the delivery from each warehouse to each customer, and that's going to give us our objective function, right? So this is quite simple. We've run through objective functions from day one when we were looking at linear programming, right? Now we're going to come to our constraints. Now, the constraints are quite simple, right? In transportation LP, the constraints we need to look at right now are the customer constraints. So this is how much the customer is requiring that they get delivered to themselves, right? So customer one has requirement of 35,000, right? Customer two has requirement of 22,000, and you need exactly that. And that's why over here we have an equation WOCT plus WTCT, which means warehouse one to customer two and warehouse two to customer two is equals to 22,000. This customer doesn't need more than 22,000. They don't need less than 22,000. They need exactly 22,000 items, right? So that's the first set of constraints. The second set of constraints has to do with the warehouse availability, right? So warehouse one has a certain number of items available, right? They just have 6,000, right? But you don't need to send an entire 6,000. So if you're sending goods out to be delivered to customers, you can send only up to 6,000. That's why we have less than or equal to. But it's important to note that. The same thing with warehouse two. They have stock up to 8,000 items. So if you're sending stuff out, once again, you can only send stuff up to 80,000, right? And then we deal with our non-negativity, which means that we want to make sure that the values we get for our decision variables are positive. We've run through that already. And then we also want to make sure they are integers, which basically means that we're not going to have decimal values, right? So now the solve is here. Instead of running you through what the solve is here, I'm going to create it, right? We're going to create it together, and then you see how we solve this, right? So I'm going to skip this because I just quickly ran through that. I don't want to waste time in this video. So what we basically need to do is to, let me just at least start, let me copy. What you usually want to do when you are setting up a transportation LP problem is to copy this table, right? Usually this table will be given to you. You want to copy this table, except for this part. You just want to copy the costs per item, right? So I'm just going to copy that. I'm going to come back here. I'm going to paste it, right? Everything looks fine for now. But I'm showing you the method that is easier to use for transportation LP. And this is very important. This method is, I prefer this method because it's easier to see if you're making errors, and you can go back and troubleshoot to check what errors you've made, right? So after I've copied this table, I copy it again, and I just come down maybe here and paste it. Now what's going to happen is that I need to delete all these values because this is where my decision variables are going to live. So I'm going to come here and I'm going to just format. I'm just going to make it automatic so that once I hit 1, okay, that becomes a number and not a currency. Let me also take these borders off. Good. Right, so basically what's happening is that this table up here is giving us the cost per item. This table down here is going to give us, or this is a decision variable we are looking at, which basically is going to be the amounts that we're going to send from each warehouse to each customer. So once again, this table is looking at the cost from each warehouse to each customer. This table is going to look at the amount we're going to send from each warehouse to each customer, right? Now, note that I told you that the warehouse have certain availabilities or capacities, and each customer has certain demands, right? So what we're going to do is we're going to type over here maybe demand of the customer. Let me bring it down here. Demand. And then if we realize we're just going to copy from the question, right? So I'm going to copy this. I'm going to paste it here. Right? So customer 1 has this demand. Customer 2 has this demand, so on and so forth, right? We also have availabilities for each warehouse, right? So each warehouse only has a certain number of items. So I'm going to put over here, I'm going to type in availability. Let me just put in capacity. No, let me put in availability. Availability, right? So warehouse 1, if we read from the question, it says warehouse 1 has 60,000, warehouse 2 has 80,000. So let's just quickly type that in. 60,000, 80,000, right? And then we're basically going to put our sign over here. So in this case, we said that this is how much availability warehouse 1 has. So if we're sending items out of warehouse 1, we cannot send more than 60,000. So that means whatever it is we are sending has to be less than or equal to that, right? Also for warehouse, we have to be less than or equal to that, right? So basically, we're going to put over here delivered, right? So when we solve our LP problem, it's going to give us how much we need to deliver or how much will be delivered, right? And I'm going to compare that against our availability, right? So we're going to put some formulas here. I'm going to leave it blank for now. We'll come back to that. Right over here, what we're going to do is we're going to type in received. So this is what they demanded, and we have to make sure that we also have another row for how much was received by them, right? By each customer, right? That's also going to contain a formula. I'm going to leave it blank for now. Let me put in a sign. For transportation problem, usually you want to make sure that the amount that they receive is equal to the amount that demanded, right? You don't want to give them more because that doesn't make sense. You're a company, you don't want to give them more than unless you're running a promotion, right? You also don't want to give them less because they asked for this amount. You don't want to give them less than the quantity they requested for, right? So basically, instead of having less than equal to or greater than equal to, we're going to have equal to. Some of you might have noticed that if you try putting the equal to, it's going to accept a formula. So if I put equal to and I hit enter, we're getting an error, right? So let me show you what you need to do. Let me expand this to around 150%. If you want to put in an equal to sign and let Google Sheets accept it as an equal to sign, you have to use the single quotation marks and equal to. And when you hit enter, it does equal to. All right, so I'm just going to copy that and paste it. I'm going to center this. Focus on the formatting later, right? Let me just reduce this a bit. So basically, we have something set up, right? This is where our decision variables are going to live. We're going to put in a formula here. We're going to put in a formula here. And we're just going to make sure that these meet the criteria. This also meet the criteria. So this is basically constraints. And there's also the other set of constraints, right? So let me just, to give it a bit of formatting, I'm just going to format this a bit so we know the values you're working with, right? Now, how do we know the amount that is delivered? We're just going to do a very simple function, right? We're just going to sum them up. So we're going to sum up everything in warehouse 1. Currently, it's going to be 0 because there are no values in there. I'm also going to sum this up, right? Same thing for the received, but in this case, I'm going to sum it. I'm going to sum up the amount that customer 1 received, right? I'm going to copy and paste this formula. So you also realize that this is the amount customer 2 received, this is the amount customer 3 received, right? So if I start putting in values, 10, 45, realize that customer 3 received 55 items and 10 items were delivered from warehouse 1, right? So these are just seed values I was using, right? So let's just take that off. So you know that our formulas are working, right? Let me just try and center everything here just to make it consistent. Good. Now, the last thing we need to do is we need to create our objective function, right? So basically, that's going to give us the total cost that's going to be involved, right? Because these are just costs for one item from each warehouse to each customer. So we need to find a way of calculating the total cost. So I'm going to click on this cell, and I'm going to use that as a objective cell. I'm going to just highlight that a bit, right? And basically the formula is going to be equal to some product, and this is where you need to pay close attention, right? So it's going to be some product. I'm going to select this entire array, comma, to go to the next array, right? So it's just asking for array 2, and I select the second array, right? They're supposed to be the same size. This is 2 by 4, this is 2 by 4, they're the same size. I hit enter. Runner is going to be 0, which makes sense because we don't have anything here. And I'm going to format it as a currency because it's supposed to be in dollars, right? So let me just quickly explain what the sum product does, right? So basically what it's saying is that multiply this by this, plus this times that, plus this times that, plus this times that, plus this times that. I think you get the picture, right? Instead of putting that formula that way, which is quite long, you can just use a sum product, because ideally what you want to do is you want to multiply the cost per item from warehouse 1 to customer 1 times the number of items that you're sending from warehouse 1 to customer 1, right? And you want to do that for each of the deliveries, right? And then you're going to get your total cost, right? So this is very simple. I've not formatted it, very well. I'm quickly going to show you what I did to format it, and this has a bit more explanation, right? So I'm going to increase this to 150%. So basically, you can see over here that we have our values. These are the cost per unit, right? This is where our decision variables are going to live, right? This is the amount that is going to be shipped. This is the capacity of each warehouse. This is the demand from each customer, and this is the amount that each customer is going to receive, right? So I'm quickly going to solve this. Let me just expand this, go to Open Solver, add-ons, Open Solver. Okay, Open Solver is up, right? This part is usually quite easy, but it's where a lot of people also make mistakes. So make sure that when you're putting in the values, you do it properly, right? So it's asking for objective cell. I have mine all the way here, so I'm going to click on that and click on Update, and it picks up the cell that you're currently highlighted. So I'm going to pick that up. basically what we want to do in this case, we want to minimize the cost. So we're going to keep this at minimize, right? It's asking for our variable cells, that's our decision variables. Realize that in this case, for transportation, this entire area is going to be our decision variable cells, right? So we're going to have 1, 2, 3, 4, 5, 6, 7, 8 decision variables, or you can just multiply this 2 by 4, right? So I'm going to select this entire range and click on add. Then I'm going to go to our constraints. So this is our first set of constraints. This is our second set of constraints. And remember that we have the non-negativity constraint that's already been checked over here, and we have the integer constraints, right? So let's start with the first constraint. I'm going to select these two. I'm going to click on update. I'm saying that these two should respectively be less than or equal to the capacity. So let's update. Okay, now let's select the capacity. We update that. And then hit save, right? So we've stored in our first constraint, right? So for the second constraint, I'm going to select all these. I'm going to update that. And I'm saying that this has to be exactly equal to the amounts that they demanded, right? So I'm going to select that and also update. So I save that. I also have to make sure that because I'm sending items, I don't want to send 4.5 items or 17.2 items. I want to send whole numbers, whole items, right? So I have to make sure that all the decision variables that are coming here are going to be whole numbers, or sorry, they're going to be integers. So I'm going to select this. I'm going to click on update. In this case, I'm not comparing it with any other thing. I'm just going to select integer. And once I do that, you realize that I cannot even select anything down here, right? I'm also going to hit save. And basically, we've put in our 4 constraints. So it's basically this first one, second one, the fact that this has to be integers, and then we already have the non-negativity checked here. When you're using OpenSolver, you have the ability to do that, right? So at this point, I think I can start solving and wait for my solution. Right. So you see that it's given us values over here. It's advising us that we need to send 35,000 units from warehouse 1 to customer 1, 22,000 units from warehouse 2 to customer 2, 3,000 units from warehouse 1 to customer 3. Sorry, I think I made a mistake. So basically 35,000 units from warehouse 1 to customer 1, 22,000 units from warehouse 1 to customer 2, 3,000 units from warehouse 1 to customer 3, and then it's also advising us to send no units from warehouse 1 to customer 4, right? We're rather going to be sending 30,000 units from warehouse 2 to customer 4, right? And you realize over here that the exact amount that they demanded is what they received, right? And you realize that over here, the capacity was exhausted in warehouse 1. So everything from warehouse 1 was sent out. For warehouse 2, right, not everything was sent out, which satisfies the constraints. But I realize that we have about I think 35,000 units that are still remaining in warehouse 2, right? So there's opportunity for this company to still send items to another customer, right? So what I want to see in your conclusion also is to just state what I talked about, right? Also talk about the fact that this is going to be optimized solution, right? This is going to be the minimized cost or the minimum cost that you can that's going to this is going to be the minimum cost in your transportation, right? Considering all these constraints, right? It's good to also notice that you have 0 units here and talk about what these 0 units means, right? So this is not a mistake. Some of you were asking me sometime whether this is a mistake if you have 0 in your decision variables. No, that literally means that to optimize the solution or to minimize your cost, you don't have to send any units from warehouse 1 to customer 4. I want to see that in your solution, right? You can also talk about the excess inventory that you have and what you can do with that, right? It helps me know that you are critically thinking about the solution that you've come up with, right? I don't want this video to be long, so I'm going to pause it here. I want you guys to go back and solve more questions, and then if you have any issues, please reach out to your facilitator, and then yeah, we can do that. Remember, your formative deadline is still Thursday evening. If you have any issues, please reach out to your facilitator. It's very important that you keep them in the loop of any issues you might be having in terms of the submitting the formative, right? Okay, thank you very much.